addresses of 1.1, 1.2, 1.3, 172.16.1.0 subnet. They're all sharing it. And so what you do is you use the command no frame relay inverse ARP, and that turns off inverse ARP. Since inverse ARP is off, we have to map DLCI to the IP address, and this is the command frame relay space map space the protocol IP 172.16.1.2 is the next hop address, which would be router B, and DLCI of 20. So this DLCI is going to be 20 right here, representing this virtual circuit. And if router A sends something out of the virtual circuit with a DLCI of 20, he'll end up at the IP address 1.2 for the next hop. Broadcast allows the router to simulate the broadcast messages. So any message that's a broadcast that would normally go out of the serial 0 interface would be turned into unicast messages and sent out each virtual circuit. So again, I would know this command, frame relay, map, IP, next hop address, DLCI, and then broadcast allows the simulation of the broadcast message. This is next hop. This is the protocol, pretty much going to be IP most of the time, and then frame relay map. This says frame relay, this says map. So I would definitely know the components of this command. Now let's go in and take a look at a point-to-point environment and how we would configure that. Let's take a look at an environment with a point-to-point setup. So here is serial 0 on the Palestra central router. It has a global DLCI of 10. We have Palestra A, Palestra B, and Palestra C. Global DLCI of 20, 30, and 40, respectively. We're going to look at Palestra Central's configuration first. So since we're going to need to create sub-interfaces, on serial 0 we get rid of the IP address. We go no IP address, encapsulation frame relay, and remember we don't see it, but it's specifying Cisco as the type field there. Then to create the sub-interface, we're basically chopping serial 0 up into multiple virtual interfaces. Virtual interface point 1, point 2, and point 3. And it actually acts like 3 separate physical interfaces. So to create the sub-interface, that's it. We just type it in. Interface serial 0, point 1, and then we have to specify the type of interface it's going to be. Point-to-point or multi-point. In this situation, A connects to, or central connects to A, central connects to B, central connects to C, but there is no connection between A and B or B and C or anything like that. So everything routes through the central router. Once we have the sub-interface created, we specify the IP address, and in this situation it's going to be 3 different subnets. The connection to Palestra A is 1.0 subnet, Palestra B 2.0 subnet, and Palestra 3 or Palestra C would be the 3.0 subnet. So there actually are 3 different subnets that the IPs are going to be in. So you see IP address for this sub-interface point 1 here of 1.1. The next step is mapping the virtual circuit to the sub-interface. So each sub-interface hosts its own virtual circuit, and that's frame relay interface DLCI 20. So DLCI of 20, which means ending up at the router with a global DLCI of 20, is Palestra A. So it's saying, hey, that sub-interface that will host that virtual circuit is .1. Then you go to serial 0.2, create an additional sub-interface, point-to-point. IP address 2.1 this time for, again, this is the 0.2 sub-interface, and mapping DLCI of 30 to it. So again, you're saying, hey, this virtual circuit will host DLCI 30. And interface serial 0.3, point-to-point, 3.1 IP for the appropriate subnet, and then map DLCI 40 to it. So Palestra Central will see 3 DLCIs, 20, 30, and 40, and the next hop router would be A, B, and C, Palestra A, Palestra B, Palestra C. To find out the IP addresses of the next hops, inverse ARP would take place, unless we wanted to statically map it using that frame relay map command. Let me clear this off and we'll take a look at the configuration of Palestra A. Here's Palestra A's configuration. Same thing, interface serial 0, get rid of the IP address, encapsulation frame relay. Serial 0.1, point to point, give it the IP address of 1.2 because it's the 10 subnet, and we're saying, hey, this guy has a global DLCI of 10 for Palestra Central, so you're going to go interface DLCI 10, map this DLCI of 10 to the sub interface 0.1. Same thing for router B and router C. Let's pop those up real quick. And here's the config. I'm drawing a line in between the two of Palestra B and Palestra C, which are down here. Here's B, here's C. Same thing, the only difference is the IP address. And the reason the DLCI is the same is because the global DLCI of Palestra Central is 10. That means Palestra A looks at a DLCI of 10, B looks at a DLCI of 10, C looks at a DLCI of 10, because that's where they're headed. So 2.2, because this is the 2.0 subnet here, so this subinterface has an IP of 2.2. And for Palestra C, 3.2, because this is 3.0 subnet, so this guy's got an IP address of 3.2. And again, frame relay interface DLCI applies the virtual circuit to the sub interface. Now let's go take a look at the last one where we have a mesh and a point-to-point interface. So one's going to be multi-point, the other one point-to-point. This is called a partial mesh. So we've got serial 0 interface, a global DLCI of 10 for Palestra Central, 20, 30, and 40 for Palestra A, B, and C. And the big difference here is there's a point-to-point connection between A and C, or Palestra Central, I'm sorry, and Palestra C. Palestra Central, Palestra A, Palestra B have a mesh environment. So this is called a partial mesh because you have any-to-any connectivity in this area between Central A and B, and then just a point-to-point connection between Central and Palestra C. So in this situation, we'd create two sub-interfaces, serial 0.1 and serial 0.2, one to host the multi-point environment and one to host this point-to-point connection. So we need two subnets. Same thing as before, interface serial 0, encapsulation frame relay, enter, no IP, and then you go serial 0.1 and you specify multi-point. You're basically telling the router that more than one virtual circuit will be mapped to this interface. Give it an IP. This whole thing right here is the 1.0 subnet, so this IP is 1.1 for this sub interface, and you're mapping DLCI 20 and DLCI 30 to it. And again, inverse ARP would tell us that IP address of, let's say this is 1.2 and 1.3 for the appropriate sub interfaces. Inverse ARP would map that information for us. Then you go to the point-to-point interface, serial 0.2, and that's this one over here, 0.2, and give it an appropriate IP address. This is subnet 2.0. And so this IP is 2.1,